Hello, everyone, and welcome back to my YouTube channel. I hope many of you would already be aware of this concept, which I'm going to talk about. The topic for today's video is compute versus storage and why we should scale compute separately and storage separately and why we should decouple them. So, it might be obvious for many of you, but yesterday when I was having conversation with someone, and then when they said that, hey, we have a lots of load on our system, so we'll just increase all our resources of our system to cater the load. So it's a very generic statement when you say that you have a lot of load and you just need to increase all your resources for your system. So it gets important for you to understand the subtle difference between various types of resources which your system has so that you can scale in the right way. And this question came from the concept of caching. So should we use in-memory caching or should we put the data into some external storage like Redis or somewhere else and then get the data from there? So let's quickly get started. Now, before we talk about compute versus storage, we should talk about what happens in a machine which is running your software. So when your software runs, it eventually runs on a machine. It can be your machine, that's your local machine, or it can be some machine on cloud which has some public IP address. It can be hosted on Azure or AWS, etc. And that particular machine which hosts your software can have some of the properties like how much CPU does it have. For example, it could have a 2 gigahertz processor, 4 gigahertz processor. It could be from various vendors like Intel, etc. It can have various properties like hyperthreading, etc. So those things can be there in the CPU. Then you have RAM. It could be 8 GB RAM, 4 GB RAM, 16 GB RAM. Based on your use cases, you might want to load more data in memory. In those cases, you can increase the RAM. The third is the disk. So you have a hard disk in your machine, which is a persistent storage. It could be HDD, it could be SSD, etc. So SSDs are the more powerful and more faster compared to the HDDs. So you can have all those things. Above and all, you can have a network capability assigned to your machine. So for example, it could only transfer the data up to 100 Mbps, or it could only transfer the data up to 1 TB per second, etc. So there can be some configurations for your machine and you are limited by those configurations. And at times you have to optimize for that. It doesn't mean that if you have lots of resources, you just increase your disk to 1 TB, you just increase your RAM to 64 GB, and you increase your CPU compute power to, let's say, best one, whatever is available. You don't increase everything, you increase what is needed. So that's the question we need to answer. And I think it might be obvious as well that should I use storage and DB in the same machine as our code or not? So it means that, let's say your Java code is running, you have a REST API to get some user field or something for someone. You made a DB call, you got the data, and then you return the data to the user. You can put that data into the cache. And now you have two options. You could put the data in memory as well. So there are some of the interfaces like @cacheable in Java, which allows you to cache the data in memory as well within the same machine. Or let's say you can even put the data in the database hosted in the same machine. You could do that. You have a VM in that you can install two softwares, one for Java, other for your database, and then you can connect. Or you have a separate machine for storage. So you have a compute resource and you have a storage resource. So should you and can you do that or not? That's the question. So the important concept which I wish to talk about is that storage is not directly proportional to the compute. So if you look a simple diagram here, that on the left side, I have a compute and on the right side, I have the storage. So the compute can be your Java application or your Python application, which is hosting a REST API, or it is doing some kind of operation. It's a service running on the cloud. Many times it can happen that you have petabytes of data in your storage, a large amount of data, but there are very less users. So in those cases, this compute can scale differently compared to the storage. So storage, you can buy a lots of storage, let's say a petabytes of data, but you don't need that much amount of compute. Maybe your one web service would be enough to handle the request of, let's say, 200 daily active users. So you have just one backend service to handle all your daily active user. You can have two maybe because of some fault tolerance, but two is just okay because you have very less users, but you need a large database with a large disk to handle the petabytes of data. Basically, you need more storage compared to the compute resources. So that's one thing. And likewise, it could happen that you have, let's say you have a gaming company and you are having a gaming applications or gaming backend servers, and where you have made a commitment that you will not store customers' data. You are not going to store much of a data. In those cases, you will have lots of computation which will happen in your backend services, but you will need very less storage for your service. So it could happen either ways. You can need more storage and less compute, or less compute, more storage. And the proportional thing can also be true. There can be cases when you need both, and there can be cases where you need none because nobody is using your service. You don't even have enough data. So all these four combinations are possible, and you would want to buy the hard disk separately, that's the storage layer separately, and you would want to buy the compute resources separately, so that if you want, you can shut down your machines. So that's possible in the compute layer. So let's say somebody is having a Java application running on 5 backend services. If there is no load, they can shut down 3 and they can just have 2 in the compute layer. But in the database layer, it's mostly persistent. So once you buy a database, moving the database across shards is just hard. Let's say you have 5 shards for your database, and then you want to delete 1 or 2 shards. Then you have to move the data from the shards which you wish to delete to the shards which you want to keep. So that process is a little hard. So that's it. I think I might have clarified and made this point clear that you would want to have a separate resources, separate scaling for compute, separate scaling for storage, so that these both can scale independently and they don't hinder with each other. So yeah, that's it from my side for this video. I hope this video was helpful for you. Till the next time, bye.